Hello everyone, Saidu here. Welcome to another CCNA Server Ops Lab. Now in this lab, I'll be creating hashes with OpenSSL. But before we dive into creating these hashes, let's have a little background knowledge on hashing. Hash functions are mathematical algorithms that are designed to take data as input and generate a fixed size, unique string of characters, also known as hash. Now, one of the advantages of hash function is the fact that they are very hard to reverse. That is, it is very hard to recover the data that created any given hash based on the hash alone. Another cool feature of this hash function is that even the smallest change done to the input data yields a completely different hash, which we are going to see in a bit. Like I made mention earlier, I'll be using OpenSSL to create this hash, but there are other tools available that you can create this hash with. Now I am on my terminal window here, so I'll change the directory to the home analyst lab.support.files, and then inside this directory I have a file named data2grandma.txt. So I'll go ahead and cut this out. Now, so you can see this is the content of this letter or this file, which is a letter to grandma. So we have them here, something that is readable and we can make meaning out of it. So now this is my input. This is the file that I'll be using as the input in order to create the hash. Now the command that I'll be using will make the use of MD5 as the hashing algorithm to generate a hash of the text file. Now I'll go ahead and use this command OpenSSL space MD5 space my input, which is letter to grandma.txt, which is letter to grandma.txt. Now I'll hit enter from my keyboard. All right, you can see the output here. The output are these hash. So that is the output of that input or the letter to grandma now being changed to this hash message. Now, hash functions are useful for verifying the integrity of data, regardless of whether it is an image, a song, or a simple text file. So, the smallest change result in completely different hash. Hashes can be calculated before and after transmission, and then compared. If the hashes do not match, then data was modified during transmission. Now, let's demonstrate this using the same letter to grandma. So inside this letter to grandma, I will change the letter M. Instead of hi grandma, I will change to hi grandpa. Let's demonstrate this by modifying the letter to grandma.txt file using the nano text editor. Say nano letter to grandma.txt. Alright, from this letter now, I'll change the M, which is grandma, or change the grandma to grandpa. So notice that the only letter that I change here is M. So I'll save it and I'll go back to my terminal window and create the hash using the MD5. Say open SSL space MD5 letter to grandma.txt. Then I'll hit enter from my keyboard. Now you can see that the letter or the new hash is completely different than the previous hash. Why? Because I changed the letter M here. Now that is how to create hash and how to verify or compare two hashes. So MD5 hashes are considered weak and susceptible. There are other robust hashing algorithms which include SHA-1 and SHA-2. Now to generate a SHA-1 hash of the letter to grandma.txt, I'll simply use this command. Say open SSL SHA-1 or you say SHA1 space letter to grandma.txt. So after hitting enter from my keyboard, now this is the result of the SHA-1. But something to note is that other tools exist to generate hashes. Some of them are MD5 sum, SHA-1 sum, and SHA-256 sum can be used to generate MD5, SHA-1, and SHA-2-256 hashes respectively. So I'll go ahead and demonstrate the use of the MD5 sum to hash the letter to grandma.txt. So now from my terminal here, I'll enter md5 sum space later to grammar.txt. So I'll hit enter from my keyboard. Now this is my output. So if you check this output, which is the md5 sum, and compare it with the one we hashed earlier, which was OpenSSL MD5, you find out that they are having the same output. They're having the same hash message. So I'll demonstrate that of SHA-1 sum. Now from my terminal, I'll enter SHA-1 sum space later to grammar.txt. I'll hit enter from my keyboard, and then this is my output. Also, the SHA-1 sum here generate the same hash message as the SHA-1 we used earlier. As I mentioned earlier, a common use for hashes is to verify file integrity by comparing the hashes. Now, I'll use this simple command to check the hash of this file, which is file is img underscore sha256.6. So I'll now cut it and see the content of the hash message, or I want to see the hash message. I'll simply use the cat sample.img underscore sha256.6. Now that is the output. So I'll now use the sha256 sum to calculate the sha256 hash of the sample.img. So basically, I'll use the sha256 sum and then enter the sample image, which is supposed to be the input, and I already have this file here on my system. So I'll simply enter sample.img and then hit enter from my keyboard. Found out that the hash message are similar with what I had before. Now, the fact that these two outputs are the same testify to us or the user that the file has not been tampered with during transmission. Alright guys, that is how to create hashing using OpenSSL and how to verify hashes. I hope you learned something from this video, and I will see you in the next one. Thanks.